Alrighty, welcome back. So in the last, or I guess 2 videos ago, we saw a bunch of different errors. We learned about what causes them. Then we saw how to raise our own errors. But really the most important thing in this section is all about handling errors. Right now, if our code gets an error, it kind of breaks everything, stops execution, and everything just halts, and it prints out that error to us in the terminal, and we're kind of screwed. But that changes right now, because now we're going to see how to actually handle them, how to do things if we get an error. If we encounter one type of error, do this. If we encounter another type of error, do this. So obviously, this is a good idea. It's strongly encouraged to use try except block. So that's the magic that we're going to learn here, the new syntax, try and except. So here's an example. This on its own is not that impressive, but it's a very simple example. If I just had a file, actually let me just copy this and I'll show you. Paste this into a file and let me just call foobar on its own. And if I run this, what do I expect to get? We get a name error. Yep, that's kind of review. There's no variable called foobar, no function, nothing existing. So by writing this code as try foobar, what I'm basically saying is try to do this, and then we have this except name error, except name error, and you can do this as syntax, we'll come back to that, but let's just actually leave it at the most simple possible thing, like this, except, and then print problem. And then afterwards, let's do another print down here that just says like after the try. Okay, so what it's going to do is try this code, which, yeah, it's a very silly, simple line of code, but it will cause a problem. And without try and except, our code would break. This would never run. But because it's in a try and except, try attempts to do this, and then if there's an exception, this runs, instead of the error being thrown and everything getting messed up. So let's try it now. We now get problem, and then after the try. So hopefully that makes sense what's happening here. If we just did foobar and then tried to print after foobar, we're not going to get anywhere. None of this will even run if I do this right now. The very first line ruins everything. So instead, we put it in a try block. Now, this is a very simple example and also is not without its own problems because, for example, printing out problem like this is just not a good idea. We're not explaining what the problem is. We're not actually handling an error in a helpful way. And also, this is very generic. There could be any sort of error. In our case, this is a name error. We know it's a name error. I have a slide actually devoted to this. You don't want to catch all errors with a blank except like this, because what will happen here is anytime there's an error, whether it's a type error, a name error, anything, divide by zero error, they all will be caught by this except and will always print you tried to use a variable that was never declared, even if that wasn't necessarily the case. So what we want to do instead is be specific and we accept particular errors. Like in this case, accept name error. And that way, we're only going to run this code if we encounter a name error. And if there's another type of error, this won't run. And we can actually add another except afterwards, and I'll show you that in just a moment. So let's start by actually building a little function that might be useful. So you know how, and we saw this in the last video, if I define a dictionary like this, and we have a name is Ricky, like this, and then I try and access something that's not in there, we've already seen this before, what type of error will I get? We get a key error. Let's say we want to make a function called get. And what get will do is take in a dictionary, I'll just call it D, and then a key. So I would call it like this, get D, comma, city. And it should check if city is in this dictionary, and if it is, it should give us the value. If it's not, instead of throwing an error, a key error, it should, return none instead, or false. There's actually already, dictionary.get that we've seen. So we're kind of redefining our own version, except it's just a function. It's not a method on the dictionary. So for this to work, we need to define our function. And the code that we just run looks like this. D of key. So this is the dictionary of the key, but that could potentially throw an error. So we're going to try that code. And then we want to accept, and we can just do all exceptions, but let's do accept key error. All that we'll do is return none in this case. And we'll do a return D key. So return the value by putting the key into the dictionary. So if we called get with D, comma, name, we would try to access D of name, and that should be Ricky. But if we tried to do it with something like city, as we saw, then that will throw a key error. We will intercept it here and return none instead. So let me show you how that works now. Just move this after the function definition. And now if I call this get D, comma, name, and let me print it so we can see the result that we get. We get Ricky, all right? Not surprising. But if I try city, which doesn't exist, we get none. So instead of getting an error, which is what we would get if we did it on our own, like this, that would give us a key error. Instead, we get the value none. So we've now written a function. It's basically mimicking, the existing dictionary method d.get, where we could pass in city. This is just our own version. So you probably wouldn't do this yourself and build this all out, but this is essentially what's happening behind the scenes. It's trying just to return the value based off of that key, but if it gets an error, it returns none instead. I will end the video here, but we still have a little more syntax to talk about as far as try and accept blocks. So in the next video, I'll show a couple more examples.